Good day, engineers. So, itong video natin na to will be for the last problem, which is sample problem number 3 on the topic for the shear strength of soil. So, still para to sa course na Foundation Engineering. So, start na natin yung discussion for our last sample problem. So, for our sample problem number 3, sabi dito, a cylindrical clay sample having a height of 8.5 cm and a diameter of 3.3 centimeters undergoes an unconfined compression test or UC test. This soil fails at an axial load of 300 newtons and shortens to a height of 7.5 cm. So determine the following. First, the angle of internal friction. Second, the cohesion of the soil. And third, the stresses on the failure plane if the angle of rupture plane is 68 degrees. As you can see, dito sa given natin, sabi na agad doon that this is an unconfined compression test or AUC test. Magtataka ka bakit ka pinapahanap ng angle of internal friction. So, pupunta ka dun sa item C na required. Sabi dun, may angle of rupture plane siya na 68 degrees. Ibig sabihin, this one is greater than the theta which is 45 degrees. So, meaning, hindi niya pinapa-assume sa'yo na yung more envelope is horizontal. So, that means, magkakaroon ka nung kung ito yung more circle mo, so, kung nandun siya sa 0, 0 na point, ibig sabihin, meron ka dyang angle nung theta. Then, this one is 2 theta. And, hindi siya straight line. Kasi nga, meron kang given na angle of rupture plane. So, for our given, yung mga given natin is yung original height, which is 8.5 cm. Yung original diameter, which is 3.3 cm. Yung final height na 7.5 cm kasi sabi sa problem, it shortens to. So, that is the final height. Then, yung axial load or axial deviator load is the 300 Newton force. Then, lastly, yung angle of the rupture plane is 68 degrees. Ang required sa atin is yung angle of internal friction, yung cohesion ng soil, at lastly, yung stresses sa failure plane kung yung rupture plane natin is, or yung angle of rupture plane natin is 68 degrees. So, to solve this one, ang gagawin muna natin is i-convert lahat ng centimeters into meters at yung newton into kilonewton. So, doing so, unahin natin yung original height. So, 8.5 centimeters. So, that is multiplied by 1 meter over 100 cm. So, it will give you 17 over 200 meters. Then, going to the original diameter, 3.3 cm times 1 meter over 100 cm, we will have 33 over 1,000 meters. Then, for our final height, we will have 7.5 centimeters times 1 meter over 100 centimeters. So, it will give you 3 over 40 meter. Then, the axial load, which will be converted into kilonewton. So, that will be 300 newtons times 1 kilonewton over 1,000 newtons. So, it will give you a value 0.3 kilonewtons. So, upon converting those units into meter and kilonewton, so ngayon, we can proceed to determining the stresses or the stress required. So, syempre, pwede tayong gumamit ng two methods. So, pwede natin gamitin una yung rule na conservation of volume. So, that means yung original volume is equal dun sa final volume. At pwede rin natin gamitin yung dinerive natin na equation from our concept, which is part 4 of the video on the concept of the shear strength of soil. So, unahin natin yung method na conservation of volume, whereas volume original is equal to the final volume. So, syempre, meron tayong equation ng original volume, which is area original times length original or height original is equal to area final times length final or height final. So, arranging the term, ang kailangan kasi natin dito yung final height or yung final area nung soil sample natin. Para ito kasi yung gagamitin natin to get the stress or the deviator stress nung soil sample natin. So, that will be equivalent to area original times length original or height original divided by the length final or the height final. Then, we have this equation. So, saan galing to? Yung area original dyan is ito. So, galing lang yan sa equation or sa rule na ang area is pi over 4 d sub o squared. Kasi nga, the base of the cylinder is a circle. So, that means this is the area of the circle. Then, we just substitute HO and the height final, which is 3 over 40. So, calculating that one, our calculator will give you 9.6934 times 10 raised to negative 4 meters squared. Since nakuha na natin yung area or yung final area ng soil element natin, ngayon pwede na natin makuha yung actual deviator stress or yung normal maximum principal stress natin from the actual load divided by the final area. Kasi yun na yung stresses natin at failure. So we can see that will be sigma 1 is equal to 0.3 kilonewtons divided by 9.6934 times 10 raised to negative 4. So calculating this one using our calculators, it will give us 309.4889 kilopascal. Alternatively, makukuha natin to by using yung derived equation kanina. Pero syempre, makukuha natin yon kapag kinuha muna natin yung change in length niya at yung strain. So, getting our change in length, we have the height original minus the height final. So, substituting the height original and the height final, we have 17 over 200 minus 3 over 40. We will have a change in length of 1 over 100 meters. From the principle naman ng strength of materials, the equation of strain will be the change in length divided by the original length. So, this one will give us delta H over the HO. So, substituting the change in length and the height original, we have 1 over 100 divided by 17 over 200. And this will give us a strain of 2 over 17. Now, itong strain na to is gagamitin natin dun sa derived equation natin from our concept on the shear strength of soil, which is the part 4 video. So, substituting that one dito sa equation na to, which is sigma is equal to P times 1 minus strain over area original. So, isubstitute natin lahat ng values. So, that is 0.3 kilonewton times 1 minus 2 over 17 divided by pi over 4 times 33 over 1,000 squared. So, this will give you as well ng sigma 1 is equal to 309.4894 kilopascals. Ito na ngayon yung normal stress natin tsaka yung maximum principal stress or siya rin yung actual deviator stress natin. So as you can see, meron siyang discrepancy on its third and fourth decimal. Pero medyo maliit yun. That is just 0.005. So, medyo acceptable pa siya for that discrepancy. So, ngayon, magpo-proceed tayo in getting other records ng problem natin. So, first, kunin natin yung Morse circle. Pa-plot kasi natin dito yung nakuha nating sigma 1 or yung delta sigma. So, since this is an actual or this is an unconfined compression test, so, syempre, yung plot natin is magsa-start on the 0, 0 coordinate. Siya kasi yung minimum principal stress. Then, adding the deviator stress will give you the sigma 1. So, this means that this sigma 1 is also our delta sigma kasi equal lines lang sila. So, from this Morse circle, pwede natin makuha yung value ng 2 theta dyan. Since given tayo ng value ni theta which is 68. So, kunin natin si 2 theta. So, that is 2 times 68. And our 2 theta will be 136 degrees. So, since napalabas na natin yung 2 theta, balik tayo dun sa Moore column failure diagram. So, kung may 2 theta tayo dito, we can use it supplement yung angle alpha para makuha yung angle of internal friction na required sa atin. So, we first interact or we first use the supplement na angles or supplemental angles na alpha at 2 theta. So, creating an equation, we could have alpha is equal to 180 minus 2 theta. Then, substituting 2 theta, we will have alpha is equal to 180 minus 136. Then, calculating, we have an alpha equal to 44 degrees. Now, since meron na tayong alpha, pwede na nating gamitin si triangle BCD para makuha yung angle of internal friction na phi. So, alam natin na a triangle has an interior angle of 180 degree. So, doing so, meron tayong equation na phi is equal to 180 minus 90 minus alpha. Then, substituting the value of alpha, we will have phi is equal to 180 minus 90 minus 44 degrees. Then, calculating that equation, it will give us an angle of internal friction of 46 degrees. Now that we have the angle of internal friction, balik tayo dun sa Morse circle natin. So, sa Moore column failure diagram natin, as you can see, kailangan natin humanap ngayon ng paraan para makuha si cohesion. Hindi natin pwedeng gamitin si triangle BCD kasi wala naman sa kanya yung cohesion. Si cohesion is pwede nating gamitin itong triangle na to, pero since wala tayong makukuha dyan, we just have to see the bigger triangle which is triangle OCB or OBC. So, meron kasi dong mga given na delta sigma over 2 to, tapos ito delta sigma over 2 din. And this one from our previous sample problem, we take this as C over tangent of phi. So, extracting triangle OBC, ito siya. So, as you can see, nandyan na yung C over tangent P. Ito na si delta sigma, and ito na yung delta sigma over 2 na isa. So, from the principle, angle B will be a 90-degree angle since it is an intersection of a radius and a tangent line. So, from this triangle also, makikita natin na yung angle of internal friction, opposite niya, si segment BC, at yung 90-degree angle, opposite niya, yung segment OC. So, we can consider segment OC as the hypotenuse of our right triangle. So, from that one, we could use the sine function. So, using the sine function, we have sine of phi. So, opposite is delta sigma over 2 and the hypotenuse will be c over tangent of phi plus delta sigma over 2. Substituting values or arranging the value since ang required sa atin dito is yung cohesion. So, we arrange the values for uh, para ma-determine natin yung cohesion. So, ito, imumultiply natin dun sa sine of phi. So, it will yield us this equation. Then, after having this equation, as you can see, pwede natin i-divide both sides by the sine of phi. So, that one will yield an equation C over the tangent of phi plus delta sigma over 2 is equal to delta sigma over 2 sine of phi. Ngayon, our next one is to rearrange ulit natin yung term para mapalabas naman yung silang. So, ang gagawin natin is i-transpose natin to papunta rito. So, it will become, from positive, it will become negative. So, that will give us C over tangent of phi is equal to delta sigma over 2 sine of phi minus delta sigma over 2. So, ngayon, si tangent of phi, simumultiply na natin dun sa mga equation na nasa right side para makapag-yield tayo ng equation for our cohesion which is delta sigma over 2 sine of phi minus delta sigma over 2 multiplied by the tangent of phi. Substituting the values, we have 309.4889 divided by 2 sine of 46 minus 309.4889 divided by 2 times the tangent of 46. Our cohesion using our calculator will be 62.5208 kilopascal. So, yan ngayon yung makukuha nating cohesion by using triangle OBC. Now na meron na tayong cohesion and angle of internal friction, balik tayo dun sa more column failure diagram. Ang kailangan na natin ngayon i-determine is yung stresses dun sa failure line natin or stresses at failure. So, yun yung nasa point B. So, dito na natin gagamitin yung triangle BCD since sa kanya included yung shear stress na kailangan natin which is the shear stress at failure. So, extracting triangle BCD. So, ito siya. So, ang una nating makukuha syempre will be the shear stress of the soil or the shear stress at failure ng soil natin. And as you can see, si angle of internal friction, ang adjacent side niya is si tau. And meron na tayong hypotenuse which is delta sigma over 2. So we could use the cosine function. So using the cosine function, we have cosine of phi is equal to tau divided by delta sigma over 2. Then arranging the term, we could have tau as equal to delta sigma over 2 cosine of phi. Then substituting the values, we have 309.4889 divided by 2 cosine of 46. Using our calculators, it will yield tau of the failure line or the tau for failure is 107.4945 kilopascal. So ito na ngayon yung required sa atin na shear stress at failure. So, ngayon, malaki yung magiging importance dito ng segment DC which has a value X. So, pwede natin siyang kunin, same pa rin, using the sine function or through the Pythagorean theorem. So, by using the Pythagorean theorem, we have X is equal to delta sigma over 2 squared minus tau squared. So, we will substitute the values. So, that is 309.4889 over 2 squared minus 107.4945 squared. So, our value X will be 113.3139 kilopascal. So, yung sigma ngayon is, or yung sigma at failure is mapapalabas natin by subtracting x2 delta sigma over 2 kasi this length is delta sigma over 2 which is the radius of our circle. Then, para makuha natin yung sigma which is ito kasi yung sigma. So, ibig sabihin, from here, babawasan natin yung delta sigma over 2 natin ng segment DC which has a value x. Doing so, we have sigma f is equal to delta sigma over 2 minus x. Substituting the value, we have 309.4889 divided by 2 minus 111.3139. Calculating that one, we have the stress at failure or the normal stress at failure which is equal to 43.4306 kilopascals. So, ayan na ngayon yung stresses at failure na hinahanap natin. Summarizing that one, we have the angle of internal friction which is P is equal to 46 degrees. The cohesion of the soil which is 62.5208. And the shear stress on the failure plane which is tau F is equal to 107.4945. And the normal stress on the failure plane which is sigma F is equal to 43.4306 kilopascals. So that will be our last sample problem on the shear strength of soil. And this will be the last part of the video on the shear strength of soil. So again, this is Engineer Rodolfo. Thank you for watching and don't forget to subscribe to Butch TV.